Hi, I'm Crystal.
Hi, I'm Alex.
Hi, I'm Yu Young.
And together,
we're Team Epic!
So we were assigned project number 1, which is the Sustainable Urban Planning Project.
First, open MATLAB and select the Sustainable Urban Planning file. Once the GUI interface opens, you are given an option between 3 cities, SF, LA, and Albuquerque. Once you select one of the cities, an image of the selected area within the city will appear as a grid. Then you can start selecting between 10 different brands of solar panels and 8 different brands of wind turbines/generators. Once you make your choices, you can click on the plot, and depending on where you click, boxes will fill with specific colors pertaining to the type of reusable energy selected. After you have finished plotting, the program allows you to save the image as a picture. So select Save as Picture and it saves as a .png. Then you can go to your workspace and open it, and there it is. In addition to that, you can also save it as a text output. When saving, make sure this text output has the same file name as the picture. When you look into your work command window, you can also see that it displays the amount of potential solar and wind power based on what you've plotted. Look into your workspace, and there's your text output. Within the text file is a legend that details out the brands of solar and wind items that correspond to the grid in the text file. Zeros indicate that nothing was plotted in that box. Now that you know how to save your work as an image and a text output, another feature within this program is the ability to create a bill of materials. To do so, select Create BOM and make sure to change the file name, else it will overwrite the previous text output you just saved. Once saved, go to your workspace and open it. Within the BOM, it details out the quantity of each brand of wind and solar item you have selected. It then calculates the price of each one and gives you the final estimated total of your planned work. Finally, to demonstrate this last feature, we're going to create a new grid image and then load out previous work. So we're going to replot points and save this new file as a picture and a text output. Then we're going to reopen our previous one that we named test and load it. And then it should reappear to us and allow us to continue editing it by plotting more items and then resaving this new edited work once again. If we go back to our workspace, we can see that there are new edits to this previous file, both within the picture and within the text output. Now we're going to explain some of the code that goes behind this program. First, we have 3 city buttons that display each city grid. Here we have the SF button, and first we create a separate figure for the image to be displayed on. Then we read in the images we've created of each city. Then we create a grid with the parameters of 10 by 10 pixels for each box. Then we show the image. In addition to that, this button also retrieves the image and sizes the image based on how many pixels the entire image has. Then these pixels are placed into a matrix. We divide the pixels by 10 to obtain a matrix of rows and columns that represent the boxes on the grid. After that, we initialize several variables to be used more later on in the code. We repeat these steps for LA and Albuquerque.
Okay, so for the solar button, it opens back figure 1, and then it holds on to it. And then here it retrieves, because it lets the user click on the figure, and then it will retrieve that data. And then here it will find the box that associates with where the user clicked on. And then here it retrieves the data from, or the variables from the workspace. So M is the matrix, and N1, so N1 through N10 represents the number of boxes for each type of solar panel, since there's 10 solar panels. And then here's the switch statement, depending on which one they click on. So this one is 1, this is case 2, case 3, case 4. And then it will fill that box that you clicked on based on what type it is. And then it assigns the corresponding matrix to that number, and then it increments the number of boxes by 1, and then it assigns that number back into the workspace. So it does that for all these cases, and then at the very end it will assign the whole matrix back into the workspace. And then it's the same thing for wind, except it's N11 through N18, since there's 8 wind turbines / generators. And then here's this. And then for the done button, it'll retrieve the data from how many rows there are and how many columns there are, and once again it will retrieve the data from how many boxes there are for each type. And then here we actually calculate how many of each solar panel or wind turbine / generator there is in each box, multiplied by how many boxes there are of that type. And then here's another switch statement for here, which what file output you want to save it as. So case 1 would be save it as a picture, and then case 2 it'll save it as text output, so it gets the string of what name you want to save it as, and then it opens a new file with that name, and then you get the matrix from the workspace, and then you get the name of which city you chose, and then it prints out the legend, and then it'll have a for loop that will print out the matrix, and then it closes the file. And then for the third option, the bill of materials, get the name that you want to save it as again, open the file, and then here we calculate the prices for the cost of the number of solar panels / wind turbines / generators that you have, and then here's the total, you just add it all up, and then it prints out the bill of materials.
Next up we have the power generation. In order to determine the power generation, I need to find the area of the solar panels, and I do that using the data given to me in the project description. With those areas determined, I load the database from Project 1 that contains the solar and wind data for the different cities. With that solar and wind data, I find the average based on the city, and then create variables for each different city, San Francisco, Los Angeles, and Albuquerque, based on my solar data. Next, I create a vector. With these vectors created, I then get the city that the user chooses and create a switch statement using that city. So for San Francisco, I multiply the average solar power generated for San Francisco times the number of solar panels and times the area of each different type of solar panel. I do the same thing for wind, but instead of the area of the wind turbine, I multiply it by a constant 500 kilowatts per mile per hour. Per month, yeah. With the final solar generated and wind generated variables, I then display them in the workspace using fprintf. For the load button, we have the user input a file name, which we then load using htload, and fopen opens up the text file that corresponds to the figure. Then we find the city of the image, and using a switch loop, we determine the size of the grid that will be put on the image. And in doing so, we create a matrix that will hold the data that the user decides to manipulate. This trash variable is used to get rid of any extraneous text within the file, such as the name of the different solar panels in the Los Angeles grid, etc. And we use scanf to rewrite the matrix that contains the data and use a while loop to assign all the variables and boxes filled by the user to the matrix. And finally,